let's start, Priya. Tell me about yourself.
Yeah, myself Priya. So I completed my ME in VLSI design. After that, I joined my high-tech company. I'm much interested in semiconductors one because my field is nothing but electronics and VLSI. So I'm very much interested to do job in that semiconductor. So I'm just trying to move forward to this one.
Okay. What did you, which college did you finish your degree?
Yeah, basically I'm from Chennai. So I completed my ME in Beltech Multitech. It's in Chennai.
Degree,
Beltech
degree,
Multitech Engineering.
degree.
ME.
Huh?
ME in VLSI.
No,
Masters of Engineering.
I'm asking about the degree.
That's what I'm saying. Masters of Engineering, ME.
You're talking about the postgraduate, not I'm
Okay,
asking.
just that.
You are
Undergraduate
engineering.
one.
Yeah, you are engineering, undergraduate.
B in EC, Electronics and Communication Engineering.
Okay. Which college?
It's in same Beltech.
Sorry?
Beltech. Beltech Engineering College.
Okay, fine. You did both there only, right?
Yes, both the degree on the same college.
Fine. 2018 was your MTech pass out. Fine. Then what did you do from then?
Then I just joined my IT company as a software engineering.
IT, what's the company name?
Mobac.
Mobac.
Now I'm in Mobac. Yes, I'm just working in Mobac.
Fine, that's good. Okay. What was your project in B?
My project, but I'm not that much clear. It's been a past, it's been a long time, but I can tell that by identifying that we can just detect what issues we have in our body, like what cancer issues or any heart problem or any lung problem. Using the camera, fundus camera, using that one, we can just identify what type of disease we have in our body. That's my main one.
Was it any kind of IoT thing or was it a AI based project or
No,
what?
it's on digital image processing one.
Okay, image processing.
Dip.
Okay, fine. Then what about your ME project?
Yeah, my ME project is nothing but using the SRAM. Okay, so I'm just moving up forward to use an NUCA. That means non-uniform clutch or catch architect.
Okay.
Using that, I'm just increasing the power, energy, and all energy performance.
Good. Okay. Fine. So, why do you want to get into VLSI industry?
Yeah, while studying itself, I'm very much interested to do jobs in VLSI, but I tried, I went, but I didn't get. I don't know what the correct path to do. I was a little bit confused, but my ambition is nothing but to enter into the semiconductor one. But now only I'm just getting the correct path to enter.
Fine. Is there any spark that triggered you to get into VLSI industry, or is it just you want to get into VLSI industry?
Actually, while doing MA, I don't get any spark related that one. After, while my professors have just taught me the way of thought, I'm just very much interested in that to do. By using the cadence one, circuit designs and Linux, I'm very much interested in doing the jobs in cadence. So I just become tempted on that to do.
Fine, good. Okay, we'll start with the technicals now. What are your best areas like in electronics?
Okay, my best area is nothing but digital electronics. That I like that subject very much. And next comes analog one and electronic circuits and device. This is my best.
Let's start with digital.
Actually, yeah, it's breaking.
Yeah, we'll start with the digital. Okay.
Yeah. Okay.
Fine. Can you be able to tell me about flip-flops?
Yeah, okay. So flip-flop is nothing but a one-bit storage one. We have different types of flip-flop like D flip-flop, SO flip-flop, JK flip-flop, and T flip-flop. Okay. So it's nothing but a edge-triggered one. If you give the clock in edge, it will just work. That flip-flop gets turned on. Yeah, that's it.
So
The memory element.
okay. What's
Sorry?
the latch? What do you mean by latch?
Latch is also one of the memory element. It's a level triggered one. We can use the level. We have different types like SR latch, D latch.
What's the difference between a latch and a flip-flop?
Okay, there is no much difference. This flip-flop is nothing but edge trigger, and this one is level for latch is level triggered. And we have that means for latches, the same input will get toggled, but there will be no difference in the flip-flop. That's the only difference. Both have the memory storage, 1-bit storage.
Okay. So you mean that a latch is level triggered and the flip-flop is edge triggered?
Yes.
Okay. Does a latch can't be triggered with the edge?
If you give, yes, I think. If we just modify that circuit, we can give. We can.
Like you mean to say that you can modify the circuit of latch to form a edge trigger. You sure about that?
I can say no, we can't do that one. Sorry, we can't design latch by using that edge trigger.
So you mean that the latch is different and flip-flop is different?
The clock is different. The clock cycle is different. But the circuit and that definition, that means storage, is all the same.
So you can't give the same clock which you give for flip-flop and the same for the latch also, right? You mean like that, right? Or you can give it?
We can give. Not sure, but we can't give, I think. But the circuit is same. I mean, circuit is same for flip-flop as well as for latch. Yeah, we can. Actually, we can do. I'm confident about it. By modifying the circuit, we can definitely give.
Why do you want to modify the circuit just to give a clock for that? You don't need, right?
Actually, because I'm not sure.
We'll come back to the very basics. Can you name the basic gates?
Yes, and or not, NAND nor, then XOR, XNOR.
I asked you about the basic gates.
And or not.
Not. Then you said the XOR and XNOR. What are those gates?
That's for exclusive gates.
Okay. Which two are called as universal gates?
NAND, NOR.
Why are they called as universal gates?
Because using the NAND NOR, we can design any of the gates. Like we can design AND gate, OR gate, non-NAND gate by using this NAND or NOR. So only it's called as universal gate.
Okay. Fine. Then can you design a flip-flop using any of the basic gates or any of the gates using a flip? Can you design a flip-flop using a basic gates?
Yes, we can design.
You can design?
By using the NAND, yeah, we can design. By using the NAND gate, we can design a flip-flop. NAND gate, NOR gate.
What are the inputs you give to the flip-flop?
If
consider
for
any flip-flop and you give some inputs to the flip-flop.
We can give the inputs for flip-flop as 0 or 1.
Yeah, what are the inputs for the flip-flop? I'm not saying about the thing. What are the input pins for the flip-flop?
Depends on that. pin, input pin. Suppose for SR we have 2 pins, so we can give 2 combinations.
Okay, fine.
0, 0, 0, 1, 1, 0, 1.
Hold on. I'll get you the other way.
Yeah.
You have a flip-flop named as SR, right?
Okay.
What are the 2 inputs you are giving?
Yes, or set, reset.
Okay. What's the other input you are giving to activate that flip-flop?
0, 0, that means to activate 0, 0, 0.
You need a clock, right?
Sorry, correct. Yes.
Clock is an input, right?
Yes.
So if you are constructing a flip-flop using a NAND gate, how can you give a clock to the flip-flop?
Actually, by connecting, one more NAND in between that we can give. Actually, the design will be right 4 cross coupled inverters. Okay. So by connecting a NAND, we can give the gate. Sorry, clock.
Okay, fine. How do you generate a clock, or how do you give a clock to that? How do you give a clock to that input? The clock needs to be right. You need a clock to operate a flip-flop. Fine. We'll.
Yes.
It's okay. We'll move forward. What do you mean by multiplexer?
Multiplexer is nothing but where we can give many inputs and we can get only one output.
You can give many inputs and get only one output. Are you sure about that?
Yes.
Many inputs and get one output.
Sorry. One input and many outputs. Correct.
One input.
Many outputs.
Sure about that?
Yes, I'm sure.
Then what do you mean by demux? Demultiplexer.
Many input and one output.
That's where you are struggling. Are you sure about these two? Many input, one output is demux, mux, or multiple inputs and one output. Which one is correct? What do you mean by mux? Many input, one output, or many output, one input?
Many input and one output is nothing but a multiplexer.
Okay, then what is demux?
Demux is one input and many output.
One input, many output. Okay. So what are the inputs for the mux? If you have a 2:1 mux, if you have a 2:1 mux, what are the inputs for the mux?
2 power n is to 1. So n is nothing but a number of, we can say number of bits.
Bits?
So 2 power, 2 cross 1, 4 cross 1, 8 cross 1, 16 cross 1, 32.
Fine. What do you mean by 2:1 mux? What do you mean by 2:1 mux? How can a 2:1 mux be?
2:1 mux is nothing but where we have a 2 power n is 1. So we can use one select line and 2 input.
If you need to get 2 power n as 1, what do you put the n as? What's the power of 2 power what is 1? As per you, what you are saying, what is 2 power n makes you get a 1?
Actually, I am confused. Wait once again. I will just. Okay, so 2 power n is to 1. So 2 across 1 is nothing but where we have n is 1. So n is nothing but select line. 2 is the input and 1 is output. Suppose 4 cross. Okay.
Can you imagine how a mux looks like in a diagram in your mind? Can you imagine it? If you can imagine, take your time. If you can imagine and say something from your diagram, what you are going to imagine, let me know. If not, then I'll give you a hint.
I will I actually I'm a little bit confused. Actually, can you give me a hour? I'll just go through. Sorry for that. I'm a little bit confused with all that one.
Fine.
Is it
Okay. I'll tell you one thing. You just
Yeah.
try to figure it out. You have a box, red on a box.
Mm.
You are saying 2:1, right?
Mm.
2 will be the inputs for your multiplexer, right? And
Okay.
on 2 input, I01 and I0 and I1, right?
Yes.
Okay. You will get an output Y, right?
Yeah.
So if you have 2 people to pass through a gate,
Yes.
only one person can pass through a gate.
Yes.
So you need a watchman to allow one of those person. And we call that watchman with a particular name in multiplexer. What's the watchman name?
Select line.
That's it. That's what I was expecting from you. So 2:1 mux has.
2 input, 1 output.
That's good. 2 input, 1 output, and what else? 2 input, 1 output, and what else?
On select line.
Okay. Now you said the 2 power n, right?
Mm.
So write down 2 power n equals 1.
Okay.
If you means you have 2 input lines, right? So
Mm.
from 2 input lines, you are getting 1 output,
Yes.
right? So 2 power n of 0 gives you 1. That's neither anywhere related to your whatever mux. It's not related to mux. Okay. So if you have two inputs, you need one select line. Okay. To select them. If you have 4 inputs, how many select lines do you need?
2 select lines.
Yes. You got it? If you have 8 inputs, what's the select lines?
2 power 3. 3 select
Yeah.
lines.
Now you got it, right? 2 power 3. So what?
Yes. 2 power n is to 1.
1 means your select line. Got it?
Okay. Fine.
Right? Okay. This is how it is. Fine. Can you define fan out?
Fan out is nothing but how many inputs that it's used to drive the circuit.
I'm
Suppose
talking
we
about
have
fan out.
fan out is nothing but same. That means how much input used to drive the circuit. Suppose we have many outputs, so same outputs can be driven by the many inputs. So that is not fine.
Sure about that?
Yeah.
Is there anything that come related to the voltage in this? Is there anything that comes like voltage without changing voltage? Does that happen anywhere in fan out or fanning?
No, I.
The maximum number of similar inputs that can be driven from the IC without changing the voltage. Voltage difference.
Input. Okay.
Got it?
Without.
Fine. Now, you know about encoder?
Yes, yes.
Yeah.
Okay, encoder is similar to the marks one. Here, 2 power 2 power n is to m. So m is nothing but a number of output, n is select line, and that is known as encoder. That means 2 power n is to m. Okay, so same as a multiplexer, many input and one output, where MS depends on the output line and N is nothing but a select line.
One output will be there. Are you sure?
No, M outputs.
M outputs. So can you give an example of an encoder with numbers like any, this is to this encoder?
Yes. Suppose I'm taking 2 power 3 is 8 is to 8 is to 3. So encoder.
8 is to 3
Encoder.
encoder. So what will be 8 in your 8 is to 3 encoder?
8 is input. 3 will be our output. Yes, the select line will be.
You will have a select line in encoder. Are you sure?
No.
Then what's the difference between encoder and mux?
Here we don't have the select line. Okay, suppose we have 8. We have input as Y0 to Y7. If I select any, suppose I have the input as 0, 0, 0. In encoder, I will get as 3 bit as 0, 0, 0. Sorry, if I select Y0, so I will get output as 0, 0, 0. If I select Y1 means 0, 0, 1. Like this, I will get the output.
Okay. How do you select them?
By using the enable pin.
Okay. You didn't mention the enable pin. You have to mention the enable pin. Okay. So the thing what you have to correct is that when you are going with the encoders, you have to mention the enable pin. When you are going with the multiplexers, you have to mention the select lines. These all are common things. Okay. You have any idea about counters? Synchronous, asynchronous? Yeah. Can you explain something about the synchronous counter?
So we have 2 types of encoder, ring counter and Johnson counter.
Synchronous counters.
Okay.
I need just specifically say what is synchronous counter. Just define it in a brief way. What is synchronous counter?
Synchronous counter. Okay, synchronous counter is nothing but where in flip-flop we can give the clock. You can give each and every clock to the input. That is not synchronous counter.
No, you can't.
Suppose the clock is given to all the flip-flop.
Okay. Which clock?
Which H triggered clock.
Fine. Can you be more specific with the inputs of the flip-flops?
Sorry.
Can you be more specific with the inputs of the flip-flops?
Okay, suppose D flip-flop has 1 input, that is 0, 1. You're asking like that.
Fine. You have 4 flip-flops. Okay, consider it's a ring counter. So
okay.
How do you give clock to each of these flip-flop?
By using the H trigger, we can give only by using one clock. We can connect.
Did you understand my question? Did you understand my question? You understood?
I understood.
Okay, but I'll tell you. See, the thing is, you have to connect all the clocks, all the inputs, clock input will be given from the same clock. Okay, all of these will be synchronized. That is why you call them as synchronized.
Yes.
Right?
Okay, that means I want to give the clock to all the flip-flop. If one
Flip-flops.
clock,
The same clock
okay,
which you are giving to the first flip-flop will be continued with the second, third, and fourth.
Second.
All will be given at a time. So if once you give a clock, every flip-flop will be activated. That's why it is called as synchronous clock. Synchronous, right? What is asynchronous flip-flop? Can you define right now about this?
yes, asynchronous is nothing but just giving one clock to the first flip-flop. The output of the first flip-flop is given clock to the next flip-flop.
Good.
Same
Now you
execution.
got that.
That
Now
means
you got
first flip-flop will just do the execution, then only next flip-flop will get activated, then like this goes on.
okay, fine, fine. What do you mean by a clock?
Clock is nothing but just an input. We want to get activated for any device, we'll give a clock. It's even as a pulse or can say pulse type one.
No. I asked you, what do you mean by a clock? Define a clock.
It's nothing but a time interval, reciprocal of the time. Oh, sorry. It's just input one for a time interval to activate.
You join the other meeting link I'm sending again, okay? I think this is ending. This meeting is going to end now.
Okay.
Digital and we'll move to Verilog, okay?
Verilog, I think I have only digital interview as well as STL, STM.
Okay, fine, we'll move to STA, okay? What do you mean by STA?
Static timing analysis, it's nothing but a time verification. If one of the circuits needs a time constraint to check the time one, we'll just check all the times like maximum delay, minimum delay to check that one. So only we're just moving to that one.
Okay. So what happens if there is no STA in the circuit or if in the design? What happens if you don't do STA in the design?
If we don't, means there will be maximum delay that we don't require, right? The performance and that power area will get, that needs to get enlarged. So we can't maintain that. In VLSI, the main thing is nothing but the performance needed, area needed, and as well as the power. Okay. So if you don't give concentration on timing, means we'll get a maximum delay that we don't require, because the speed is also very important for us. So we are just moving on to check the timing.
Right. What is setup time?
Setup time is nothing but then inputs to be stabled before the clock triggers.
Okay.
That is not, because the output will get uncertainty. The output will get changed if you just, it's not stable means.
So that you call it as a setup time.
Yes.
What do you mean by setup slack then?
It's nothing but an arrival time minus required time.
So, I need something specific with the waveform. You can't just say formula.
Okay. So the difference between arrival time and the required time is known as a step-up slack.
Yeah, I got that. Can you explain that in a waveform? Like what is setup slack, when where you can find the setup slack?
Okay, in between that clock arrays and that input must be stable. In that we can just calculate the arrival as well as required one.
Okay. What do you mean by a negative setup slack?
Negative is nothing but an the opposite, or that means I am not clear. That means arrival time plus required time.
How? Why do you do arrival time addition with your required time?
Yes.
Okay, tell me the formula of setup time. To find out the setup time, what do you do?
Setup time. Okay. Setup time is nothing but
Okay.
it's
Rama,
greater.
I'll
Yeah.
tell you one thing. Thing is, you just don't need to make complicate with these things. Okay. The thing is, always you need to consider setup time and hold time as simple. Okay. The thing is, your clock signal before the clock signal happens, that is the positive edge triggered, there needs to be a data present. Okay.
Okay.
The time before the data needs to come is the arrival time.
Okay.
Have a particular duration, that's a required time. Before that, the data needs to arrive, whatever the signal needs to come, that's the arrival time. So your signal needs to come before the required time. So if the required time is greater than the arrival time, your slack will be positive, means you are not having any setup violation. If your required time is lesser than the arrival time, means the signal is coming lately than the required time, or whatever the required time, then your setup slack will be negative. Got it?
Oh, fine. Okay, that means okay. I got it. I got it.
Now, can you say the same thing with respect to the hold time? What do you mean by hold time? What do you mean by hold violation?
Okay, so hold time is nothing but the inputs to be stable after the clock triggers. And whenever if the input changes means the output will be uncertainty. And the hold time valuation is nothing but required time should be, yeah.
You said something. Can you repeat what is hold time again?
Okay. So hold time is nothing but inputs to be stable when after the clock triggers.
How can an input be stable after the clock trigger? You will be having the outputs, right?
Actually, yes, that means at the following edge of the clock, the input is to be stable at the hand. Okay. Then only the output does not have any uncertainty at the following edge.
You are talking about the setup again. I'm talking about the hold.
This one thing, that means after the clock signal ends. That means setup is nothing but before the clock. This one is after the clock.
After the clock, whatever you are getting is input, right? As per you. Is that input or output? Or a signal?
Just repeat once again.
Okay, I'll clear something for you. Whenever there is whenever you're talking about a setup time and hold time, you never consider input or output. Okay, it's just a signal. So before the clock triggering edge, whatever that comes before is your setup time. Okay, whatever comes after the clock is your hold time. So the thing, whatever you are getting is the signal. That's it. It's nothing. Okay? It's not an input, not an output. Okay, the signal, once that comes after the clock edge triggered, whatever you're getting, right, that will be considered as a after that is the hold time. So for particular time, the data needs to be hold. So here hold time, this is what you call it as a hold time, the time for which the data needs to be hold, that's the hold time, or the signal needs to be held. Okay, so here what happens is that the required time will be less and the arrival time will be more. Okay,
be greater, yes.
Okay, so the slack will be negative here. Okay,
and then opposite of that will be positive, right?
Right. Okay, so for some particular duration, the data needs to be stable. Why? Because the next edge will be right at that, in the next edge, the signal needs to be passed, and that should not come lately, or that should not come too early, so that it would collide with the other signal, or it would make the data loss. So it will come at a particular time. So when it needs to come at a particular time, it needs to be held for some time. That's called as hold time. Okay.
Yeah, okay, got it. But means I mistakenly said that input, that you should not mention that input.
Nothing about the input. You need to focus something about setup and hold. Okay. Have you heard about Slack? Slack.
Yes, lag is nothing but the difference between that arrival time and the required time. Or you can say the start point, difference between start point as well as end point.
You call that as
In
slack?
more,
No,
yes.
slack is
Mm.
something different.
Yeah, this only I saw in slack. That means start point minus end point.
Fine. You know anything about the DTA?
D?
TA, dynamic timing analysis.
I heard, but I don't that much. I don't have awareness of that.
You have
DTA.
any idea about the difference between dynamic timing analysis and static timing analysis?
Yeah, yeah. I have knowledge, but little bit, but not that much.
Right. Okay. So have you analyzed any reports of static timing analysis, or have you analyzed any reports of static timing analysis?
No.
Okay.
Actually, I saw that graphs, but I didn't go through. I saw that video.
Okay. What do you mean by net delay?
Net delay is nothing but if you're passing from one circuit to another circuit, there will be some delay occurring or network issues. That is known as net delay.
No. You sure about what you are saying?
Actually, the delay is taken from the network, that means all wire one from one device to another.
I'll give you an example. You have an
Mhm.
flip-flop 1 and you have a flip-flop 2. You have connected combinational circuit in between them. Now your output of flip-flop 1 Q to the input of flip-flop 2, that is D. You have some circuit in between them. Now if you have to say a net delay in this circuit, which one would you consider as a net delay?
F2.
Huh?
No. Actually, first one is F1, right? Flip-flop 1.
Yeah.
Second one is flip-flop 2. In between, we have that combination circuit.
Hmm.
For flip-flop 2, it will get delay because it takes some time to give some wire to combination circuit and to the.
Fine. You have understood everything wrongly. Net delay is the wire delay. Whatever you are going to get a delay from your wire, right? So from flip-flop 1 to combinational input, you have some wire. So you expect that to happen in a instant, but that doesn't happen. It will have some nanoseconds of delay. So that delay is called as net delay. Okay. So have you heard about on-chip variations?
No. On-chip is nothing but a size, power, area
Variations.
to the chip one.
Fine. Leave it.
Chip design.
Do you know anything about launch and capture flip-flops?
Launch is nothing but the first flip-flop while entering the signal. Okay. So whatever we get, it just launches and captures nothing but used to catch that one.
Yeah, you are
The
saying
flip-flop.
something that's what I have said in the question. Can you be specific with your launch and capture flip-flops?
Launch. Launch is nothing but uses that launches the input. I saw like that only. Capture is nothing but used to catch that whatever signals comes in the output.
Fine. Okay. Okay. Can you have any idea about the paths, different paths?
Yes, we have critical actually time path, critical
No.
path.
I'm not talking about those paths. some paths between the registers? Do you have three
Like
different paths?
input to output path, registered. No idea.
Fine. Have you heard about reg to reg path, register to register path?
Yes, yes, yes. That means
Oh.
one signal is passed from one register to next register.
Okay, fine. Now, what do you call the first register in reg to reg path?
It's a normal launch.
What?
Launch or launch flip-flop.
Yeah. What do you call the second flip flop?
Capture.
That's it. You got it right.
Yes. Okay.
In
That means
reg to reg, the launching flip flop or the first flip flop that is going to transfer the signal, or the launch flip flop is first flip flop is called as a launch flip flop. The second one is called as a capture flip flop, which is going to receive the data or receive the signal from the first flip flop. Okay. And have you ever worked on any tool like Synapse?
yeah, it's been long time, and Vivada. That's why I'm just typing that very long codes and all in that Vivada. That's it. There are only two tools I used: Cadence and
Okay.
Styling.
Okay. Then, do you know anything about jitter? What do you mean by jitter?
Because it is nothing but any unwanted wire constraint. I'm not wrong, but I'm saying that some unwanted wired constraints or network constraints. All right.
Okay. Fine. We'll end this mock here only. I'll just give you some feedback. Okay. You have to work very hard on digital from the first to end. You have to start to work on digital. You might get some notes, books, or if you go on search in LinkedIn, some pages do provide the notes for digital, and even in VLSI for all, you can look for digital basic notes and start to study. You are very much lagging in the digital. That's going to affect you. You're somewhat okay in the STA, but not up to the mark. You have to look into the STA part also. Okay.
Yeah,
You have to start working on STA. Everything you need to know what is setup time, what is hold time, setup Slack, hold Slack, setup violation, hold violation, everything. And even you need to know about the clocks, paths, reg to reg, reg to out, into reg, everything. All the four paths. And you have to have the idea about jitter, skew, slack, everything. Okay. And you should be able to solve a problem on STA also. Okay.
Okay, that means for STL, it's only that definition part is required or anything else.
You have to be specific with the STA. If someone asks you about the static timing, what do you mean by STA? You should not just abbreviate it as a static timing analysis and leave it. You have to go in depth. Static timing analysis. Why do you do it? What's the need and what's the output of it? Like what's the outcome? And what's the need of STA in the IC? Okay, what's the need of STA in the process of building an IC? Okay, try to be specific with whatever you are answering. Okay, you just give a general answer, be specific so that the interviewer doesn't take you anywhere else from what you are answering, because sometimes interviewer will catch your answer and drag it till the end of the interview to make sure that you stuck in that loop, and you know that you are not so confident about what you are answering in that answers. If you don't know, just say that no sir, I haven't studied that, or I need to recall, I don't know. But you can't say the same answer to all the questions. Okay, you prepare well. Start from today. It will help you by the time when you get into a company. It will help a lot to crack more interviews. Be specific. And the other thing is, whenever you are attending an interview, just don't lean forward. Just be sitting in a comfortable position. Okay, you always need to be sitting in a comfortable position. Keep the angle straight. The video angle should be always straight. If you are attending an online interview, sit comfortably and calmly, just like this. Okay, don't sit like this, or just don't sit like this. Just be comfortable. Take your time. If you stuck anywhere, that's okay, because the interviewer doesn't want you to fail. He just give you the time. You can ask for a second, give me a second, sir. You can take some deep breath, again get back to where you left, and you can continue. It doesn't matter. But the interview expects an answer from you. It doesn't want you to. He is not interrogating you. He is interviewing you. So he expects the answer. Okay. So once the interviewer asks you a question, be to the point. If he asks you more about the question, define. It's okay. If he asks you about explain, you need to explain it. Unless and until he asks you about explain, you should be specific with the answer. If he asks you about define and brief, you need to be specific with the answer. If he asks you to about explain, you need to explain the thing, whatever he is going to ask you. Okay.
Yeah.
Prepare well. All the best.
Thank you for your time. Next time I will definitely attend this very best one.
That's good.
I'll answer all the questions. Yeah, thank you so much for your time. Yeah,
All the
bye.
best. Thank you. Bye.